They're gonna know.
They're not gonna know.
They're gonna know.
They're not gonna know.
They're gonna know.
They're not gonna know. Let's talk about the comparison test. The direct comparison test. Oh boy. For series. Let this series and that series be two series with they're both positive sequence and AN is bound by BN. They use BN because it's bigger. I don't know. What we do know is that AN is smaller than or equal to BN and they're both positive for all N. Fancy like ketchup. Let's catch up and see what happens here. Now, we have it bounded, so if the dominant series, the one on top, converges, then so does the smaller series. Now, if the if the lower series, look at it, the lower series, this one dominates, this one's lower. If the lower series diverges, then the upper series diverges too. Similar, that one, if we talk about it, the top series, the dominant series, if it converges, meaning it adds up to something, then the one under it has to add up something to 2. So, okay, so down here, if the lower series, the smaller series, does not add, then the top series cannot add too. Remember, add is in addition. Add is in addition, series is add. Let's see what this is about. I know. Remember, not remember. You probably got here because you just did the integral test, the last video. On the integral test, we could estimate under and we could estimate over. If the under diverged, the over diverged. If the over converged, then the under converged. It's the same idea, but now it's discrete. See what I did right there? See what I do right here? I've got this dominant sequence and this subsequence. This dominant sequence is always bigger than that subsequence. What we're really looking at is dots. The dot, the dot, dot, dot. These dots are always bigger than those dots. If this series has a convergent, if this sequence has a convergent series, then that one is going to be forced into convergence. Now, if this sequence has a divergent series, then this sequence is going to force the top one to diverge. I heard. I'm over here. Oh, there you are. Okay. Wobbledy-wobbledy-wah. What do we need to do? We have a game plan. Whenever you are using the direct comparison test, then you're going to pick a direction. You are going to try to see whether or not a series converges or diverges. You're going to look at it and you're going to be like, it looks like it's going to converge. If it looks like it's going to converge, then you're going to try to get over it. You're going to look at it, you're going to be like, it looks like it diverges, then you're going to try to get under it. Because if you get under it and show that diverges, then the one on top diverges. If you think it's going to converge and you get over it and that one converges, then the one under it converges too. So once you pick a direction, then show whatever you picked to bound it by. If you pick a sub, show that it is sub. If you pick a dom, show that it is dom, meaning always greater than or always smaller than. Once you pick that direction, then you state why the simp diverges, or you state why the dom converges. Now, you're never going to find a book that says simp and dom. I'm simply just trying to be a little bit more relevant with your lexicon. Now, once you show that the simp diverges or the dom converges, then you're going to write a conclusion. And why don't you use so does just to mess with your teacher? I know, they're going to hate it, but you're going to be like, since this diverges, so does that. Yeah. Now, if we're over here, hey, yeah, in the private collection, we're not calling it private collection anymore. Now we're calling it like playlist examples or playlist secrets. Well, there you're gonna find 4 right now. As I do more, then as I do more, then as I do more, then I'll include them. So this one, look, it looks like it's all geo. So you're gonna compare with a dom geo. This one looks like it's P series. Yeah, so you're going to compare it with a dumb P series. Now you're going to try to get over it. So this one's like a little bit like, I don't know. And then this one, oh, that's bounded. Then it kind of looks like a P series. So you're going to compare it with the P series, whether you think it's going to diverge or converge. And this one, arctangent, wow, that has some limits. So you can get over it with something. And then this, that's kind of P too. Maybe I'm going to add some more where you're actually going to get some divergent ones. But that's just about all I have to say right there.